All right, welcome back everyone to our virtual planetarium. My name is Michael and we are at the Curiosity Studios at the Pacific Science Center in beautiful downtown Seattle. And we have a lot of space to cover today because today we are going to explore our magnificent moons, not just the one close to planet Earth, but a lot of the moons all across our solar system. So since we have so much space to cover, let's get started. Now, this is a planetarium show, and just like any other planetarium show we do at the Pacific Science Center, I like to ask a lot of questions. I know you like to ask a lot of questions. Curiosity never closes. So if you would like to share what you're curious about, whether it's on the screen, help drive the planetarium show, please share your questions or your observations on the chat feature. My friend Zita is on there. She can help answer a lot of your questions and share some of those questions with us. And I can go ahead and start navigating into those different places. So if everyone wants to just give a quick shout out hello on the chat feature, that's great. In fact, I got a question for you. Just go ahead and tell us, where are y'all from? I'm currently at the middle of the Science Center. Let's see, actually, I could even pull up a map while everybody's telling and sharing on chat where you might be from. Okay, you can see that we're in beautiful downtown, but let's get a little bit closer because I'm not quite at Lake Union in Seattle. I'm a little bit closer down in here, right at the Seattle Center. In fact, let's go ahead and change our navigation to be right. Well, there's my office, but Curiosity Studios is anywhere where we are asking questions, and I love to ask questions at that Willard Smith Planetarium. So if you're curious where I'm from, that's where I am right now, and I am ready to explore the nighttime sky. We have so now from Seattle and Chiron from Bellevue, and so we have some great people all around the area kind of exploring. Riza from Sammamish. This is fantastic. Now, we've got a lot to explore. So if you all are ready, whether you are from Tacoma or from Bellevue, let's get started. As you can see, I have my sky pulled up. All of the data is centered around the Seattle Center, which is pretty darn close to where Sanel is from. And I am going to go ahead, instead of looking at the daytime sky and watching the sun and keeping my navigation of north, south, east, west, never eat soggy waffles. Let's just go ahead and fast forward time and let's get to the nighttime view. And we're going to fast forward time, allow that sun to set. You know, I always love to see a beautiful sunset over the Olympic Mountains and over the Sound. But we're just going to go right past that, maybe about an hour after, maybe 2 hours after sunset tonight, so we can see those beautiful stars out. And that's what I'm really excited about. Today, I want to explore the moon. And I not only want to explore our moon, I want to explore other moons across our solar system. But before we do that, I've got a homework assignment for all of you. Now, over the past month or so, I've been telling you all to go look for Neowise. This beautiful comet has been the brightest comet we've seen in over 20 years. To go out and see this beautiful comet, go ahead and give me like a big thumbs up or a smiley face. Tell Zita about your comet viewing experiences that you've had this month. Neowise is still out there, but it's now not possible to see with the naked eye. It's a little too far away, and it's starting to lose its tail. But there's something else this month happening related to comets that I want to make sure that you know about. And as backyard astronomers, I want to make sure you are exploring yourself. And it's not over to the west. This time, we are going to look towards the east. In order to find it over to the northeast north, kind of halfway up between the horizon and right above our heads, which we call the zenith, kind of halfway up from that, you are going to see, well, look at this weird shape right here. You know, some people call that a 3. Some people call that a W. Some people in New York, they think it's an M, and it stands for the New York Mets. Well, I guess if you're Chicago and or Seattle and you're a hockey fan, maybe it's the Metropolitans. But this is Queen Cassiopeia, the Queen of Ethiopia. And we're going to use this really bright constellation and these two stars in the middle of the M to come down a little bit to right about there. And a very special constellation. Well, it's her son-in-law. It's a constellation named Perseids. Perseus was a great hero. He's the one who actually battled Medusa. And you can even see him holding on to Medusa. But if you follow those two stars, they are going to point down closer to the horizon. And friends, this month, you are going to be able to see shooting stars. There's going to be a meteor shower. It has already started, but it's going to be really at its peak next week on August 11th, 12th, and the 13th. But you should be able to see a lot of them until they get up to their peak. The peak means just like that's when the most are actually happening. And next week, you might be able to see 40, 45, maybe even 50 shooting stars screaming across the sky within 1 hour from this spot in the sky. So if you ever wanted to make a wish upon a shooting star, this is the place to look. The reason why I was connecting that to Neowise is because, well, these shooting stars come from a comet tail. Back in 1992, there was this beautiful comet, Swift-Tuttle, and it would streak across the sky and created a massive tail. But those tails and all of those little ice particles that make up those tails, they stay there. And so the Earth comes right around, and every August, the Earth runs right into those tiny little ice particles that used to make up the tail. And those tiny little ice particles go through our atmosphere where they burn up and make shooting stars. They are absolutely gorgeous. So friends, hey, out of curiosity, what would you wish upon a shooting star? If there's anything special that you want to wish upon a shooting star, share those on the chat feature. Tell Zita all about them because this is a fantastic opportunity to see a meteor shower. It's going to rain down shooting stars right down on us. And so I want to make sure that you do that all this week and especially next week. Look to the north, east, north, halfway between the horizon and the zenith. Just look for that big W up in the sky and have that big W point down to where those shooting stars are going to come from. Okay? Until then, let's explore the moon. To see the moon this week, we want to look to the south. You see, the moon has been coming out all through the south, and now it's over even near the east by this time. Let's go ahead and kind of rewind just a little bit. Oh, it's even coming out even later and later now. You see, last Monday, just 2 days ago, we had a full moon. It was absolutely gorgeous and nice and bright, and it was hanging out next to Jupiter and Saturn. But as you can see today, our moon is nowhere close to Jupiter or Saturn. In fact, it's starting to visit Mars way over there. So I have a big challenge for all of you. I want you to use your science notebooks, these little journals that you keep to make your observations. And I want you to go out at the same spot every single day at the same exact time. Draw out the horizon that you see from your spot. And then visit it every single day and draw a circle of where the moon is that night. And then you're going to do it again the next night. And then you're going to do it again the next night. And just watch the moon as it appears in different spots in the sky, even though it's the same day and at the same time. And that happens because the Earth is spinning and the moon is revolving around us, giving us different moon phases and giving us different parts of the sky that it is located. After you do that with your science journal, draw a line that connects all of those moons. You will find a very special line. It's called the ecliptic. That's the path the sun, the moon, and all the planets make as they travel across our sky. I've got a great question from one of our friends saying, what is the best place in Washington to see shooting stars? That is a fantastic question. There are some tips I have. Remember, we are going to look towards the northeast, north, close to the horizon. Here's some tricks for seeing the shooting star. Number one, you want to move away from the city lights. So we have some people who are living in Bellevue and Sammamish. And the farther and farther away you move from the city lights, the easier and easier it is going to be to see these shooting stars. The other thing is you're going to actually want to wait for the moon to go away. You see, the moon has its own glow that makes the sky really, really bright. And so if the moon could go away, that means you get a darker sky and it's easier to see shooting stars. The other thing is I often talk about nighttime and staying up late. But for this series of shooting stars, that's not always the best thing to do. You see, in the evening, we might get what we call earth grazers. These are giant shooting stars that kind of go across the atmosphere and make really long streaks. But if you want to see lots of shooting stars, wake up in the morning, go out before sunrise, maybe around 5 o'clock. Then Perseids is going to be high in the sky and a really dark part of the sky. And that's a great time to see the shooting stars before sunrise. You see how much Perseids has moved as I moved Perseids. Venus even came out. That's the third brightest thing in the sky. And then if we keep on looking up, there's Perseids. There's a satellite, it looks like. There's Andromeda NRW pointing down. It's almost right above your head. So again, my friends, it's all about direction. It's all about north or zenith. And it's all about timing. Those are when you're going to be seeing the best times to see the meteorites. How long can we see the meteor shower? Like I said, it's going to be happening through most of this month, but eventually the Earth will make it past the comet tail around August 15th. That's when they're going to stop appearing so often. It's really the 11th, 12th, 13th, and 14th. That's when you're going to see lots of them, even though they're coming out right now. Okay, now let's go visit the moon. And by this time, I think the moon has traveled high in the sky because now we are in the early morning. Jupiter and Saturn have set. Mars is now high in the sky. Can you see? You woke up really early in the morning. It's now 4 o'clock and the moon's really high in the sky. It traveled from the ground all the way up and it's making its way to being set. And let's go ahead and zoom in a little bit closer to a full moon. One of my favorite things about the full moon is all of the legends and stories about it. There are some people who think it's made out of cheese. There are some people who see that there is a man on the moon or a woman on the moon. And then one of my favorite stories comes from China. They see a rabbit on the moon. So go ahead and make your observation about this moon. It's at a waning gibbous right now, so we're not seeing a full moon, but you could definitely see that rabbit feature. So everybody look really closely to see if you can see that rabbit on the moon. Because you can definitely see it with your naked eye if you use your imagination. What I notice about this moon, I'm seeing a lot of dark features, and that's going to give me a clue of where the rabbit is. So do you see these dark features right there? There's one bunny ear. There's another bunny ear, which makes that the bunny head, a bunny body, and a bushy tail back there. And he's curled up with some bunny feet, ready to jump up into the sky. There's a bunny on the moon. I love using the bunny on the moon to help me find a very special spot on the moon. Where that bottom ear of the bunny touches the head, right about there, that's the Sea of Tranquility. That's the first place humans visited on the moon. The moon is the only place in our solar system, besides the Earth, that any human has ever been before. And it's a very special feature. There's lots of different, there's a handful of different lunar sites, but that was the very first one where a person made a small step for a man, but a giant leap for all of mankind. In fact, I want to explore a little bit more from this moon. So instead of using this feature right here, let's go ahead and blast off. All right, we are really deep in space right now, and let's get a little bit closer. Oh, I see my favorite planet. There's the Earth. And I see this bright object over to my left. Let's go ahead and navigate to our moon. Just slide right by it and fly right there. This is what a full moon looks like. And now I can really see that Sea of Tranquility right there in the sky. Follow that bottom rabbit ear. And then right where that rabbit ear hits the head, that's the Sea of Tranquility. Here's the thing about our moon. First of all, it turns out it's not all that bright. It doesn't reflect that much light. It's almost as bright or as reflective as like asphalt, like a big parking lot. But it's because we sent people to the moon, astronauts, that we've learned lots about the moon. For example, we learned why we only see this side of the moon. This side of the moon is what we call tidally locked. It is always facing planet Earth, and that's because of Earth's gravity. That's the thing about a moon. A moon isn't a planet. A moon is a satellite that orbits, revolves, or circles a planet because of the gravity of that planet. And that gravity is going to be a very important feature of all of the moons that we visit. So it was those Apollo astronauts that are the only humans that ever, well, friends, look, it is so dark back here. It is so dark. If this is a view of the moon that we would never get from planet Earth, even though the moon does spin. So let's see if we could go ahead and fast forward time a little bit and have that moon spin around the Earth and maybe revolve a little bit, so that we can see it on the other side of the moon. Friends, do you see, this is a different part of the moon that we normally don't see. You see the Earth spinning in the background, and you can see that the moon is going around the Earth, but this is the far side of the moon. And those Apollo astronauts that traveled to the moon, starting in 1968 with Apollo 8 to see the Earth rise from the moon, are the only humans who have ever seen the far side of the moon. And as you can tell, it could actually get lit up by the sun. That's because the moon does rotate, but it takes the same amount of time for the moon to rotate as it does to spin around the Earth. It takes about a month or a month, if you could believe that. All right. It's those Apollo astronauts that told us a lot about the moon because they've done a lot of things. They set up a lot of experiments, and there are some things that we have learned. For example, the moon has moonquakes. It actually shakes and vibrates just like an earthquake. Now, an earthquake could, it could just last a few seconds or a few minutes, but a moonquake caused by the gravity of the Earth can last whole hours. Oh, and some other things that they figured out. They figured out that the moon is actually slowly making its way farther and farther from the Earth. The moon is moving away from the Earth about 4 centimeters, a little less than 4 centimeters every single year. That's about the same speed as your fingernails growing. And then my favorite thing about the moon is that the moon does have water. We were always curious if the moon had water, so NASA sent up a special spacecraft, a special robot, and they basically threw it at the moon and caused a big hole just like a giant crater, and out from that crater came ice. And that's really important in case we ever want to build a mission or a base on the moon and need some fuel to come back, because we could use that water ice as rocket fuel to travel home. I love these different features of the moon. We've got Tycho, a gigantic crater. we have got these black areas where if you look, well, I don't see as many craters. That's because this area is really young and we think it used to be covered in lavas. And then, of course, some of the astronauts landing on the moon were visiting its mountains to see its different geological features. And so NASA astronauts collected a lot of rocks, brought them back to planet Earth, and what we figured out is a lot of the rocks on the moon look a lot like the rocks on planet Earth. And we think the moon was made 4.5 billion years ago when an object the size of Mars crashed into the Earth. Out from all that debris came our moon. All right. That makes our moon extra special because it's the only moon in our solar system we think actually was caused by another planet crashing into the original planet. And all of that debris from that original Earth formed this moon, now floating away from us while it circles us. But I'm not just excited about our moon today. I'm excited about some other moons in our solar system. So in that chat feature, if there's a moon in our solar system or a planet that you want to go visit right now, go ahead and share that with Zita, and she would share that with me. In the meantime, I'm going to think of some planets of my own. Let's see. There's Mercury. Mercury is really close to the sun, and it doesn't have a moon. Venus, well, that's the next planet. And even though it's about the size of the Earth, a little bit smaller, it doesn't have a moon. The Earth has a moon, and then the next planet, but it only really has one. The next planet I want to go to, just like we talked about last time, is Mars. So on the count of three, let's do a countdown from 3. Oh, and we got some friends who would say, hey, let's go to the moons around Mars. 3, 2, 1, blast off. Okay, we are going to reorient ourselves. Oh, and there was Mars. Wow. And we're spinning really, really fast. Whoa. Did you all see Mars in the background? All right, let's slow down here. Let's slow down indeed. Okay, friends, let's move. Now, this moon looks a lot different. It's not a sphere or a circle at all. It just looks like a lumpy potato. And then it's also really close to its planet, Mars. This is Phobos. It's one of the 2 moons going around Mars. And it looks and acts a lot different than our own moon. One of its things is that it's really, really close to Mars. And so it will actually circle the Martian planet 3 times within 1 day. Oh, there's Mars. You see that nice little glow? The other thing is that, well, as you can see, it's not very big. Phobos is, well, it's only about 3,700 miles around. Oh, it's only about 3,700 miles above planet Mars. But it's really, really small. And we think what ended up happening, it whips around 3 times a day. It's getting closer and closer to Mars. So that in 50 million years, it's either going to crash into Mars or it's going to break up and form a ring around this other planet. We don't think this was formed by Mars. We think that Phobos and its friend Deimos, well, they remind us of another object out in space. And to do that, I am going to visit the asteroid belt. The asteroid belt is a group of rocks in between Mars and Jupiter, where giant rocks just kind of circle around. But because of the gravity of Jupiter and Mars, they never got together to make their own planets. Friends, this is Vesta. And this looks a lot more like Phobos. So we think that Phobos might have been a captured asteroid now circling around Mars. Now, here's the weird thing about Vesta. Vesta was discovered in 1807, over 200 years ago. And when it was discovered, All the astronomers called it a planet. So when Abraham Lincoln was a kid learning about his planets, they counted this one as a planet too. It wasn't until later that they figured out it's just a part of the asteroid belt. The same thing happened in your lifetime. The same thing happened to Pluto. Why are planets and moons round? Well, not all moons are. Like Phobos, they just look like a giant potato. Vesta, even though it is 330 miles around, it's not round either. It's kind of like a squash sphere. And that's because of gravity. Different pieces of gravity come together because all the materials are kind of joined together. Here, I could give you a demonstration of why things are looking actually a little bit round. So, to figure that out, let's go ahead and look at this string. You see, gravity basically means that everything that is matter is attracted to other matter. So this part of my string is connected to this, is attracted to this part. So they join together. And then this part of the string is attracted to this part. So they come together. And then this part of the string is attracted to this part. And then this part is attracted to this part. And this part is attracted to this part. And what do we end up with? We end up with a sphere or a ball because everything is attracted to each other. If you get large enough, everything kind of squeezes down together into making a big ball. That's what gravity could do to make things round. But not everything will end up round like what ended up happening to Vesta. Vesta started off round, but it's too small to stay round. And we see on its southern side a gigantic crater. Something large hit Vesta. So large that it gouged out this giant hole. That's what happens with craters. Rocks from outer space hit larger objects, cause giant holes. And then what ends up happening is that debris floats in space. And on very, very special times, like in 1960s, rocks from that debris actually landed in Australia. There are a lot of rocks that we think originated from Vesta. Meteorites where you could touch a piece of outer space. Now, the reason why I like Vesta and we have visited Vesta and give us these beautiful images and let us know what's going on this planet because of a space mission called Dawn. It was a robot that ran around Vesta. The other reason is this idea that a lot of moons, except for the Earth moons, seem to be objects in the sky captured by other moons, including the next one. Somebody said that they wanted to go to Jupiter. It's time to go to Jupiter. All right, so if we could do a 3, 2, 1, everybody wave goodbye to Vesta, and we are blasting off all the way to Jupiter. Jupiter is out tonight. It is in the southern sky, almost due south, really close to the horizon. You will be able to see it before sunset. It is this beautiful object that Galileo used on his telescope to get a view that kind of looked like that. He didn't really get a close-up look at Jupiter. But what he noticed were these objects there and there and there. And just like you are going to do with your science journal and our moon, Galileo did with Jupiter. And what he ended up finding out, if we fast forward time a little bit, those stars seem to have been going around Jupiter. These were the very first moons we discovered in our solar system. You know, besides our own Earth moon, everybody knew about that, but no one but Galileo and his telescope knew about these moons. These are the 4 Galilean moons. It turns out Jupiter has a lot more moons. It's got about 78 moons. Oh, and Jupiter's spinning so fast, I think we need to slow that giant down. And we can see that giant red spot on this gigantic planets. Now, gigantic planets have a lot of gravity, and lots of gravity means we can have a lot of moons. And because we have a lot of gravity, we can have some really, really big moons, including the biggest moon in our solar system. Friends, this is Ganymede. Ganymede is the largest moon in our solar system. It is so big, it is bigger than the planet Mercury. It is so big, it has its own thin atmosphere. It is so big, we think that there is some water underneath layers of ice underneath Ganymede. It is so big, it gets hit by comets and asteroids, forming huge craters. Ganymede is a beautiful moon. Really, really thin atmosphere. We think it's made out of, has elements of oxygen coming from that liquid water, interacting with the solar radiation to create that atmosphere. It has geological features like mountains and craters and canyons. It, if it was by itself, would be its own dwarf planet. But it's not a planet because it circles around a planet. That makes it a moon. If we get really, really close, we could see some big, big craters. Craters so big, there's little dots in the middle where mountains formed from where the impacts happened. And we could even see streaks of that ejecta, debris that comes out when we form those rocks. That gives us an idea of actually where that meteorite came from. Do you see how there's no streaks from here? There's a crater, but we have streaks this way and this way. That tells us that the meteorite may have come from this angle, really, really low from Ganymede. All right, that is a beautiful planet, but Jupiter's moons, friends, they just get a lot weirder, including this one. We are going to another moon called Io. I want you to go ahead and share on chat what you think Io looks like to you, because NASA has a really funny description about what's going on with Io. Look at how weird this moon is. Are there any places in the universe with more or less gravity than the other? Absolutely. The closer you get to an object, the more gravity it has. So right now, if we're far away from Io, Io doesn't have much gravity on us as we orbit around it. But the closer we get, the more that matter is attracted to us and can pull us down, and we could get really close to Io. So gravity is relative to distance. And what I see on Io are, well, you see this big circle thing? You know what that is? That is a moon zit. It is acting on this moon. That is a volcano. Io is blowing out lava and sulfur and chemicals, including some organic compounds, weirdly, shooting out of over 400 active volcanoes on Mars. It does kind of look like cheese. So much, this is the way NASA describes it. NASA describes it as a giant cheese pizza covered with melted cheese and splotches of tomato and ripe olives. Do you all see those olives? Actually, you know what? This is actually making me really, really hungry. That's a good observation. So as we can see, we could have lots of geological features on Io. The other planet that's out tonight is Saturn. If it's over to the east of Jupiter, look due south, you can see it during sunsets, close to the horizon. It's got the most moons of any planet in our solar system that we know of so far. The moon that I want to visit is called Enceladus. So everybody say goodbye to Io, and we are going to travel to Saturn. There's beautiful Enceladus. And friends, I don't see as many craters on this. That means the surface of Enceladus is pretty darn young. That's because well, go ahead and tell me on the chat feature what you think Enceladus looks like. What observations are you noticing about it? I noticed that it's really, really bright. Kind of looks a little frosty too. Must be really cold out here, far away from our sun. And I'm not noticing Let's see if we can find. Oh, friends, do you see it? Do you see that streak right there? That really thin band? That must be. Oh, it disappeared. Why did it disappear? Oh, friends, that is Saturn's rings circling around that planet. And do you see how Enceladus is almost on that same level of the ring, making the rings really, really thin? You see, the faster you spin around, the more that it goes down flat, like a hula hoop or like a pizza dough. Some of my friends are saying that it looks like cheese too, and I agree. It kind of looks like a wheel of brie cheese. Something says that it has a lot of ice, like a giant snowball, like a round Antarctica. These are all fantastic observations because they are all 100% true. Enceladus is filled with a giant ocean, but over that ocean is a 20 to 25 mile crust of ice. And you see these stripe features, just like in Antarctica, it has crevices that give us an idea of what's going on underneath all of those layers of ice. Near its south pole with all of these lines, we call those tiger stripes. And those tiger stripes, well, they have geysers. They have volcanoes where water and ice comes right out, just like a volcano. But instead of lava, like on Io, ice comes out. Some of that ice gets blown way out into space, and some of the ice on Enceladus is actually adding more chunks of ice to Saturn's beautiful rings. Look at that. You see how small Enceladus is compared to that planet? I mean, if we keep on going away, Enceladus gets really, really small. But that planet, oh, it's gigantic. It barely even gets smaller. Now, there are 6 planets you can see with your naked eye. You can see Mercury, you can see Venus, you can see Mars, you can see Jupiter, you can see Saturn. And then the 6th one, well, if you look down, you can see planet Earth. That means these 2 other planets, Uranus and Neptune, don't get a lot of attention because you need a telescope to see them. But because they don't get a lot of attention, that's why I really like to explore them. So I'm going to go to our next planet, and we're going to do at least one more moon. We are going to the farthest planet in our solar system that we know of. We are going to go to Neptune. Neptune is just like Jupiter and Saturn. It is a big ball in the sky, a big gas ball in the sky. It's got stripes too, but it's just a little bit less featured. It's got rings too, but they're a lot smaller. You can see that very thin ring right there. The thing about Neptune is its wind. Oh, and it's tilted on its side. So I'm going to go ahead and fast forward time just to show you what I mean. Do you see Neptune? It's tilted. It's sideways. It's tilted on its side, and it's got a big storm too. Neptune has the strongest winds in our solar system. They go about 700 miles per hour. But do you see the spot right there? That's the Great Dark Spot. Its nickname is Scooter. Isn't that a cool name? I love the name Scooter. I'll tell you what, Jupiter has a lot more storms, and just like on planet Earth, where we name hurricanes, astronomers name hurricanes and storms on other planets. So I want you to go ahead and share on chat some names you would call different storms you might see on Neptune. Scooter has the highest winds, 17,000 miles per hour. But friends, we're not here to visit Neptune. We're here to see its biggest, weirdest moon. This is a moon called Triton. Triton, we have only visited once with a spacecraft. It was back with Voyager 2 in 1998. So we don't have as many detailed images, but what we notice is that Triton, it's really weird. It's big and icy, filled with nitrogen cliffs. And because it's so reflective, it doesn't keep a lot of its heat from the sun, which now just looks like another star in the sky. It is the coldest place so far measured in our solar system. Do you see that little dot right there? That dot is not a star. That dot is our sun. And it was here that Voyager first discovered the very first cryovolcanoes or ice volcanoes. You see, the gravity from Neptune actually causes these volcanoes to explode, but it's so cold that they shoot out ice. Just like the gravity from Jupiter shoots out the volcanoes in Io, or the gravity from Earth causes the moonquakes on our own moon. You see that little dark shadow right there? That is a cryovolcano shooting out. That cryovolcano, ice volcano, will be shooting out for over a year as it erupts. And it causes giant fields of snow, nitrogen snow, just like the stuff you breathe. And it looks like it's where it looks like a big ice or baseball or snowball. It looks like around Antarctica. The really crazy thing about Triton is that we think it was also captured because it looks a lot like Pluto and other objects beyond Neptune. Objects that keep on circling around, just like the asteroid belts, except these objects are a part of the Kuiper belt. So let's go ahead and visit Neptune again. So what we learn from the different moons is like, well, there could be lots of different moons with lots of different geological features and lots of interesting and fascinating things, including the possibility that some of these moons have organic material. Some of these moons are really good candidates for being hosts of life. I'm not seeing anything in the sky anymore. Okay, so why does it have different colors? That is a great question. Different colors means that we have different materials and elements and rocks out in space. Just like our moon has dark features and it has bright features, those are different types of rocks and materials. Why does the planet, not the moon, have different colors? It's made out of different materials. I just flew all the way to Uranus because Uranus has lots of moons, but it seems to be around the same color because all of that material seems to have been mixed up. But just like Jupiter, it has different gases. We might have sulfurs and neon gases and nitrogen gases. So they just all mix up, give us different colors. I mentioned Uranus because Uranus has lots of weird moons. They're all named after Shakespeare characters. So if, for example, I'm just picking a random one that I haven't actually even visited before. Oh, my friends, look at that. That is a weird looking moon. This is Miranda. And Miranda was only visited once by Voyager 2. It looks stripy. It looks like a lot of canyons are on it. I see some craters. Looks like it would be really, really cold. Lots of cliff faces I'm seeing. That's what those shadows mean. Oh, we had a big impact happen here. All right, well, let's visit another moon I've never been before. This is actually kind of a lot of fun. This one is going around Uranus. This is, well, we just flew right by Uranus. This is Ophelia. Ophelia looks like, well, friends, go ahead and tell me on chat what this looks like. It's not round. I'm seeing some craters. If I remember right, Uranus was over here. It gets a dark side. It looks like a giant egg. It's very, very bumpy. That's absolutely right. That means it has a lot of craters and some mountains. It looks like this big swirl right here was a gigantic impact that happened. Maybe helped squish it. So many Grand Canyons, absolutely. This one might be made out of ice, but probably it's a lot darker, so I'm thinking it's made out of a lot of different types of rocks. To me, it looks like, oh, I don't know, it looks like an egg. Maybe like a rugby football. Maybe like Polynesians were playing rugby. That's what that one was Ophelia. All right, let's try one more. Oh, it looks like an ostrich egg. That's like a great example. Let's go to, let's go back to Neptune. I haven't been in Neptune in a while. Because the really cool thing about Triton is that it's going backwards. It's going in the opposite direction of all of those other moons around Neptune. And it's getting closer to the Neptune until one day it's going to break up and form a ring around that planet. All right. So this is definitely not a sphere. What does it look like to you? Looks really, really bumpy. It looks like a giant ice cube, actually. I don't know what that looks like. This is Hellamede. Hellamede is a really, really small moon. It's only 24,000 kilometers. I mean, actually, it's smaller than that, depending on the diameter. Maybe about really, really small. And really, really bumpy. That means chunks of this stuff has been gouged out from different collisions. Let's move away from this one. And then let's navigate to my favorite moon. This might take us a while because we are on the far edges of our solar system. Oh, friends, that was actually closer than I thought. This is my favorite moon. Because without this moon helps stabilize planet Earth. It's the gravity from this moon that gives us the tides and different storms and keeps the Earth on its axis to allow us to have different seasons. It's this moon that's extra special, the only one we think of that was made by its own planet. This is our moon, and I'm going to challenge you to go look at it. Same time, same place, every night. Watch that rabbit hop up and then disappear. All right, we got a special request to go visit the sun. Now, moons, they circle around planets, but planets, by definition of a planet, they must circle around the sun. So you know what? Let's go ahead and visit the sun. 98% of everything in our solar system, all the massive material can be found right here. All of the energy that comes from planet Earth is right here. And it is dramatic, it is bright, it is white, it's middle size, but it has gigantic magnetic solar spots. Those solar spots, some of these, well, I don't know these in particular, but some of them could be more than 10 times the size of planet Earth. This is where a lot of plasma is forming, and those charged particles interact, creating huge magnetic fields that blast out from the sun. Blast out and cause solar radiation, solar wind that interacts with the Earth, causing the aurora, the beautiful, beautiful northern lights and southern lights. And then as we move away from the sun, we can see other planets circling around just like those moons were, right on its atmosphere. And we can keep on circling away. If anybody has any other questions, I'm free, but for the most part, those were magnificent moons. I love the variety, and I love those observations that you all could keep making out tonight and all this month on your science journals. For other science activities, please visit Perseids.org, Curiosity at Home. We have lots of other astronomy-related activities that you could do and record on your science journals. And then please keep supporting these programs like these. We're trying to learn a lot about how we can support school programs this fall. So please fill out a survey that I'm sure Zita is happy to be sharing with you about how we can improve these programs. That helps out a lot. And then, help us pay our own rents. We're a nonprofit organization, so all the support that we could get, particularly since we can't open our doors, go to Perseids.org/support and help us out, because curiosity never closes. All right, friends, I've got that homework assignment for you. Look for those meteor showers out tonight and all this week, especially next week, and record on your science journal the pattern and motion the moon takes at the same time, at the same place, all throughout this month. Until then, I hope you stay curious and keep on asking questions. If anybody has any suggestions about where you would like to go next on our planetarium shows, go ahead and add it to the chat feature. Until then, everybody, please stay curious. Bye, everyone.